This Camtasia video is going to address the exercise in the activity revolving around the usage of C structures. So we are going to be more specifically focusing on this series here of exercise, which are the exercise concerning the resizable int arrays, RIA or RIA, as I'm going to call them from now on. This exercise gives you a data structure. We already explained the purpose of this data structure in class. We want to be able to manipulate arrays of various size and allocate them dynamically. And for this purpose, we are going to provide all of those functions in our implementation. Another thing that you need to notice is that I want you to provide actually the code for this particular assignment as a set of .h and .c files, including a main.c file, which purpose is only to contain the main and test all these functions on resizable int arrays. So we are going to go to our Linux prompt here. I'm going to remove the slides for now, and we are going to create, as you can see, I'm already in a new directory for this project, and then we are going to create a couple of files. So we're going to create an empty main.c. We're going to create ria.c, ria.h. So I'm using the touch command just to create a bunch of empty files. Size is 0. Okay. Now I'm going to use kwrite to edit. Let's start by ria.h, which is going to contain the definition of our data structure and all of the headers of the functions we have to write. So this is going to take a couple of seconds. Here is our text editor. So we are going to start by doing all the include that we need to do. Let me go inside of the text editor, tab include, stdio, std, io.h, just in case. Okay, and then I'm going to start defining the data structure that was given to me in the exercise. Struct ria int star ptr int size. I close my curly brace, and I'm done with the definition of the structure. An alias to make it simpler to use it. Struct ria underscore t, and I'm done. Now I'm going to insert all the headers, the prototype of the function we have to write. So we're going to need a function to initialize an instance of the data structure, which is going to be passed to us as a parameter des, which is a pointer on the data structure we want to initialize. We're going to specify the size of the dynamical array when we initialize it, and we can even specify here a default value for the integers inside of this array. The second function we will define will be ria create, which is going to take simply the size and a default value. So the difference between initializing and creating, well, pretty much when we create, we're going to allocate a new instance of the data structure. When we initialize, we're going to simply take an existing instance and fill it with some values. Okay, so this is pretty much our two main functions to create things. Then we have ria destroy. I'm going to request as parameter a pointer on ria data type. The reason I'm doing that, I want this ria destroy to do more than just call free. I want it to initialize, I want it to set the that pointer to null. So for reason we already discussed in class, I need a pointer on pointer. Then I'm going to have accessors, methods that are going to help me get and set value inside this data structure. Here is set value, which is going to take a pointer on a given resizable array data structure, an index at which we want to set a value, and a value which we want to set at that index. Similar to this one, we are going to have ria get value, which is going to be similar in the parameter being passed, and it still needs an index, and I'm going to return a value this time, which is a value in the dynamic array address index. So I'm making my return type an integer. And this is it for the definition of the structure, the definition of the structure and the headers. So I'm going to go now back to my prompt, clear the error message, and try to compile ria.h. Okay, compilation of header file requested. I'm getting like a little ahead of myself here. I would have like to first use this header file to be able to do something new. So I'm going to go back to my source code, make sure it's saved, and I'm going to open another file, so ria.c. So I'm trying to close this guy here. We have now ria.h data some that I need. Okay, right, ria.c %, and this is going to take again a couple of seconds. Here's my new file. I'm going to do first thing, #include double quote ria.h, and I'm using double quote because this is one of my header files, not a default C standard library one. So what I'm saying here is that I want to be able to use everything that is defined in ria.h, including the structure and including all the headers of the various functions I'm supposed to implement. And I'm going to now work on implementing them inside of this specific .c file. So let's start by the first one. The first one was void ria. Well, let's start actually by let's start by init ria type this and size int val. Nothing for now inside of the body. So I am given a pointer on a data structure, and I want to set its size, and I want to set the value. So the first thing I need to do inside of this data structure des, I'm using the arrow notation to access the attributes since des is a pointer on the data structure. Inside of this data structure pointed to by des, I'm going to set the size attribute to the value that was passed to me as parameter. First step. Second step, I'm going to take care of setting the ptr attribute. The ptr attribute is a pointer of the dynamic array that is going to be contained in that structure. So we are going to have to do a malloc. I'm going to contain ints, how many of them, as many as size tells me. So I have initialized all the attribute of this data structure. What is left for me to do? Well, what is left for me to do is to use a little variable I, and to make a for loop for I equal 0, I lesser string than size, I plus plus. Actually, let me take that back. No, that will do. I plus plus, and I'm going to initialize all the elements of this array, that is this arrow ptr. I'm going to initialize all those elements to the value that was passed to me as parameter. If you are not sure about the precedence of the various operators involved here, you might very well just, oops, this is badly placed, sorry. You might very well want to put extra parentheses, meaning that first you dereference this, and you go inside of the attribute ptr, and then you apply the square bracket operator, the indexing operator, to the result of this dereferencing, and you assign the value val, of course, to whatever you find there. So we're done with the first function, actually, the initialization function. Now let's see how we can use it to implement the create function. The create function will actually return something. So we are going to here specify that we are returning a pointer on an object of type ria type. Ria create is the name of the function. It takes as parameter the size of the dynamical array we want to create, and it takes as parameter default value. Let's call it, well, I think the name was default val, so let's follow this convention for now. I'm going to make some room here for the code. What do we do inside? Well, first we're going to allocate the data structure itself. So let's declare a pointer on structure via T, let's call it P, and I'm going to allocate some memory for an instance of this data structure. Size of variety. So this is just like allocating an integer, except we allocate a whole data structure. So the size I want to allocate is whatever the size of the data structure is. I convert the return value of malloc into a pointer on such a data structure, and I assign it to P. Once I'm done with this, I'm going to call via init and let it do its job. Here is the pointer to the newly allocated data structure. Here is the size. Here is the default. Here is a little typo. Here is the default value, and we are done. So I'm going to save this file, and we are going to compile just to make sure everything is in order. So let me switch back to my terminal. Clear the error message. gcc via.c. Okay, here we go. What do we have in function start, which we never wrote? Okay, undefined reference to main. So here's what's happening here. This is an error message from actually the linker ld, which tells me that in the function start, which I can assume underscore start is a label where my code starts, I am trying to call main, but there is no main. Well, yes, we didn't write a main yet for our application, right? We have just been writing a couple of functions, but there's no place where we are using them. So we are going to fix that right away. I'm going to open an editor of the main.c file. This is going to take a couple of seconds again. Here we go. So what am I going to do in main.c? Well, I'm going to use those data structure and those functions. So I'm going to include ria.h. So I have access to the structure, I have all the header of the function defined. I'm going to write a basic main. Here we go. I'm going to even return 0. And inside of this, I'm going to say, well, I want to define an object of type ria_t. Yes, let's do a pointer. Let's call it P. So P is a pointer on a data structure of type ria_t, and I'm going to use the function that I just wrote. So notably, I want to do things such as P equal ria create. I want an array of 3 integers. Default value to initialize them will be 0. So this is the kind of stuff I want to be able to do. So I'm saving, going back to my terminal, and I'm going to try to compile this time the whole project. So how do you compile a project made of several files? You just specify all the .c files that compose your project. So gcc main.c ria.c. There we go. Warning, in main.c no new line at the end of the file. I can fix that easily. Save the file, go back to my terminal, compile again just to make sure. Main.c, no warning, no new line at end of file, so apparently I didn't save correctly. This is main.c, I'm saving again, going back to my terminal, and I'm trying again, and there we go, it worked. So I clean my screen. These are the files that I have right now. I have an executable a.out. I'm going to start to try to run it, even though my code is incomplete. I don't deallocate properly my memory. I just want to get a feel if there are any runtime errors that are going to be flagrant, obviously triggered even right now. So I'm running it, nothing happened. Okay, well, I'm going to keep coding, and then we'll start like developing more and more tests in the main.c to make sure every function does really what it's meant to do. Okay? Alright, so let's go back. This is the main.c. I'm going to iconify this file, and let's go back to the code for ria.c. So in the code for ria.c, I took care already of init, create. Now the next one I'm going to take care of is going to be destroy. So same thing, ria destroy, ria_t ** p, a pointer on a ria_t data structure. What do I need to do? First thing I'm going to do is I'm going to free whatever is referenced to by p, which is going to be a pointer on the ria_t data structure, and then I'm going to set *p to null. This is something that we already saw in a different context with a different exercise in class, okay? So there is nothing really transcendentally new here. What's next? Void via set value via t star des index int value. Oops, there's a typo there. I'm going too far. Int value. This one is going to be easy as well. I'm trying to say that I want to set the value at index inside of the dynamical array managed by the parameter des. So des points to a structure via t. So I use the arrow to access ptr. And I'm going to do as I did before. I'm overcautious here, but I'm saying, hey, this is what I want to do first, dereference, and then I want to use the square bracket array operators to mean that, well, I want to access element index inside of the dynamical array pointed to by ptr. Okay, and I'm going to set that to value. So this is a very easy function. However, I'm going to add here a little something. I'm going to say that if, well, actually I was going to make a little test for making sure that ptr is not null. I'm going to leave that blank for now. I'll come back to that later. Okay, this is the minimal functionality of my code here, and I'm going to stick to that for now. I want to get things working. However, if you were developing code to be intensively reused or just like production code, you would have to take care right here to make sure that when you are about to use a pointer like ptr, you want to make sure that it's not null. Okay, so we are going to leave that for the end if we have a little time. Last function of our set via underscore get value. Something. I have a via t pointer that I call des, and I have an int index. And what I'm going to return is the value of the element at index in the dynamical array referred to by the data structure that des is pointing to. So once again, being overcautious, index dot the element at index, and I simply return des value. I'm going to save my file. So far I have a lot of things. Okay, I have almost everything I need, but I'm not doing any sanity checks. I'm not doing anything to make sure that when you call me with a certain index, the index is not out of boundary. I'm not trying to make sure that the PTR is not null. So I leave this for later. However, something that I will need right now would be a variable display. It's not requested from the exercise. However, this is going to help me a lot internally to just display the content of my arrays from time to time. How do I do this? Well, I'm going to use a little for loop. I equals 0, I lesser than this array size, I plus plus, and I'm going to display on the screen, printf, an integer followed by a space, and this integer will be this arrow ptr index I. So we need, of course, to declare the variable I, and when I'm done, I'll simply printf the \n just to go to the next line to make things clean on the screen, if you will. Okay, this is it. I'm going to skip a couple of lines here, and I have approximately all the function I'm going to need. Okay, except that, like I said, I wrote them as simplistically as I could. So here's the code for Raya.c. I'm going to go back to main.c, and I'm going to try to use this code. So I already created a new dynamical array. Okay, eventually what I want to be able to do is to destroy it. So let's use Raya destroy address fp. And I'm going to make sure that Raya destroy did this job. Okay, so if p different than no, I'm going to display a little message here, printf p was not set to null. So you see the purpose of the main.c here in this project is really just to test things and to make sure that the code does what it's intended to do. Another example of that, well, printf here, if p equal null, well, I'll do a printf p was not allocated. So every time I have a problem, every time I have an error, I will display an appropriate error message to notify the programmer actually that there was a problem. And I'm adding here an exit 0 so that I don't even go further in the code. And I'm going to do the same thing for each and every error I will detect while running this code. So I'm trying to make sure that all those functions do what is expected of them. Okay, so I've been testing Raya create, which tests also Raya init. I tried Raya destroy. What about setting a value and getting a value? By default, everything is set to 0. This is what I specified on line 7. So I'm going to do p, and I'm going to call on p Raya set value. So on the dynamical array in the structure p, I'm going to say at index, well, let's see, we have 3 elements. Well, let's do index 1. I'm going to set the value, let's take something that's going to come out 9, and then I'm going to display my array via display. Actually, I'm going to also do that via display p. I'm going to do that right after creating it to make sure it's full of zeros, and right after setting this value. Last thing I'm going to test before to dismantle this dynamical array, I'm going to use a little integer v for value. I'm going to assign to it the result of calling get value, and I'm going to get the value from p, which is at index 1. That should be a 9. And I'm going to check if v different than 9. Well, then the problem is that I cannot retrieve what I put in. Value v is incorrect. So there are better ways to formulate the error message. Okay, don't get me wrong, I'm trying to do something relatively quick here. I would have to be more specific and more general at the same time about the error. I would have to say, well, I cannot retrieve value at index 1, or what I get out of the array is not what I put in there. Something that would be indicating what the problem is for a programmer, actually, not simply for Latin generic terms. Let me save this, and I'm going to close this file for now, actually minimize the window, and try to see if I can still compile everything. So GCC, let me call the last GCC I used, GCC main.c, Raya.c. Syntactically, everything is correct. Now let's try to execute the resulting executable. Segmentation fault. So now we know well that the pointer is going wild somewhere. So we have to try this error and figure out exactly where. So we are going to go back to the source code. So I'm clicking to open main.c. Okay, let's start at the beginning. I declare my pointer. I call Raya create, and well, I don't really even get a chance to do this. Okay, to check if p equal null and display p was not allocated. So something is probably wrong in the create function. Let me pop it up. Okay, there we go. It's here. Raya create is supposed to return a pointer. We have a temporary pointer p. We allocate it. We initialize it, and we do not even return it. So that could be source at least of a problem. It will not maybe fix our problem right now, but as a default value that's going to be returned automatically by C has probably nothing to do with the address that is in P, which is the real value we want to return. While I'm at it, I'm going to check real quick that the init function is correct. So index I, set the size, allocate the PTR, iterate from I equals 0, I lesser than size I plus plus, and set the value. Well, this looks in order here, so I'm going to save. I'm going to go back to my terminal, compile again, execute again. Okay, slightly better result. We have a bunch of zeros at the beginning, Okay, so if I refer back to the code, let me minimize this. If I refer back to the code in the main, yes, at the beginning I have a bunch of 0, then I have a 9 at index 1. Let's go back to the terminal. 9 is at index 1, correct? I didn't trigger any over errors, so I can assume that everything is working, right? Well, not exactly. Let's go back to the code, and this is an error that we will have more problem finding. If we go back to the code, and more specifically the destroy part of the code, you are going to see that I have free whatever is pointed by p, which is a pointer on the structure variety. Well, the problem is that whenever I allocate a structure variety, like here, line 15, I'm also allocating a dynamical array of int inside the PTR. Okay, I never deallocated this. Deallocating the structure is going to reset the pointer, but it's never going to get rid automatically of what the pointer was pointing. So I need to go back and revisit my Raya destroy, because I have a nice memory leak there, pretty much. So the solution to this is to say, okay, I want to free something, a field, an attribute, inside of the structure pointed by p. So star p is a pointer on a data structure, so I can dereference star p, dereference it again, and I can then access the attribute inside of the structure, which is ptr, and I'm going to free this attribute. Let's save, and let's figure out if the syntax is correct and if my code is still working. Syntax in function Raya destroy requires, remember, ptr is something not a structure or union, so it's not understanding I want to access the field ptr, so something here is incorrect. Let's revisit. P is a pointer on a structure star p, and I'm going to isolate it with parentheses. Star p is a pointer on the data structure. Star p is this data structure itself, and when I am on the data structure I should be able to do .ptr. I'm saving this file, and now that I've been using explicitly the parentheses, I go back to the terminal. gcc, this is it. So what this code illustrates here is the difficulty of catching the right of, I would not say catching, I would say just remembering the priorities of operators, and how easy it is to write something that makes sense in your opinion, but however doesn't follow the correct precedence of operator, and therefore will be understood differently by the compiler. This illustrates also the advice that I gave in class, which was, if you're in doubt, put too many parentheses instead of not enough. Okay, so we are now capable to compile our code. I'm going to go back in this terminal, execute it. It's still working the same. Okay, like I said, we had a memory leak. This memory leak, the only way to catch it was to actually make measurements about the amount of memory used by the process, the program in execution, and the amount of memory released at the end. Or there are tools such as Valgrind that are like readily available to help you track the kind of error. So, but I wanted to illustrate different type of error in this project anyway. I wanted to illustrate syntax error, logic errors, and how to say, errors that are less easy to test, okay, when you are writing your main.c to test your application. Okay, so pretty much, well, we are done with this